Hello, my name is Karen Hui, and I'll be helping facilitate today's webinar titled Dynamic Load Balancing with Consul and Nginx Plus. During this session, we will explore and discuss how Consul, together with Nginx Plus, can unlock the ability to drive dynamic networking operations in our load balancing environments. Please feel free to type your questions during the webinar using the Q&A feature. This webinar will be recorded, and the recording will be available after post-processing, which usually takes 2 days. Now I have the pleasure to introduce our speakers, Cody D'Arkland, Technical Marketing Manager at HashiCorp, and James Jones, Technical Solutions Architect at Nginx. We will finish with a demo and a Q&A session. I'll hand it over to Cody, who will start the presentation. Thank you, Cody.
So thanks a lot, Karen, for handing over. My name's Cody. I'm a Technical Marketing Manager at HashiCorp, focusing on Consul. And what we're going to talk about today is a little bit of how to make load balancing a little bit more dynamic using Consul and Nginx Plus. It's a little bit of a weird session because I'm used to doing the demos, but I have someone far smarter than me today helping out, James from Nginx. He's gonna take us through some really cool stuff across the number of technologies using both Nginx and HashiCorp tech. Something I want to unpack a little bit before we jump in is this concept of how can we achieve the kind of agility that people get in public cloud in environments that are typically static. And again, unpacking the statement a little bit, when you look at some of the big reasons why people left in general like the private data center and started really adopting public cloud en masse, it was really about agility. It was about being able to very quickly move, very quickly consume or get resources as you needed to consume them, instead of these long lead times for different like network constructs or different server constructs. And what's really interesting about combining Nginx and Consul together is you can achieve some of that same network agility within the private data center using those products together. And James has a really cool demo that's going to show how that works. But the kind of thing I want everyone to think about as they're watching this webinar is how can we use these tools together to get that kind of agility? And there's a really good answer there, and there's a really good path there. We're going to talk a little bit about introducing HashiCorp Consul, what it is, what its use cases are. We're going to talk about our static environments and Nginx. So that kind of this was a demo that James had done a little while back, and we're going to talk about how he took a static environment and made it dynamic just with Nginx open source. A lot of that revolved around Consul template. But then we're going to take that up a level, and we're going to talk about Consul and Nginx Plus. And finally, we'll wrap up taking a look at James's actual demo. But we're going to do this a little bit different today in that I'm going to hand over to James now, and he's going to start up part of his demo. And that demo is going to cover kind of getting the environment up and running. We're doing a lot of this live. We want to show that this can actually be accomplished pretty easily inside of your own environment. So we wanted to come in without anything majorly staged. So I'm going to hand this over to James, and he's going to take a little bit about the start of his demo. We'll come back to me afterwards, and we'll talk a little bit more about Consul, and we'll unpack some of these dynamic networking concepts, and then we'll wrap up with him showing the end result of what he built. So take it over, James.
Yeah, if you can unshare so I can show here.
There you go.
Awesome. And I just want to preface this, guys, this is a two-way conversation, while we're doing the demo. If you guys have any questions, ask in the Q&A. I'll stop what I'm doing and I'll answer it. But I just kind of wanted to show you really quickly, because this takes a little time to bake, about 15 to 20 minutes, and this will be happening in the background while Cody's going over the agenda, and just kind of show you what we're doing here. We're actually going to be deploying what I call a micro CDN, basically where we're going to be deploying a small CDN network that's going to serve packages from the Nginx public open source repo for Ubuntu and Debian packages. And we're going to be deploying 4 data centers, and then we're also going to be deploying an origin mirror. Basically, it's going to act as the origin, but it's going to mirror the apt repo above. So what I'm going to do now is just kick that off. And so we want to do this live. And they say what they say about live demos sometimes. Hopefully this one won't blow up. But I'm going to pass it back to Cody, and he can start going through the information about how we actually are achieving this.
All right, thanks, James. Just getting the sharing turned back on. and making sure my mute button is not getting stuck on. So let's start to unpack a little bit about what Consul is in the context of this. You know, we've been on kind of a tangent lately talking a lot about service mesh and Consul as a service mesh. And we just released 1.8 that had a lot of like really powerful service mesh specific features. But one of the really interesting and really exciting things to me about Consul is that Consul has a lot of things that set you up for the journey into modern application networking, right? We can start off with looking at an environment and just checking health of services and cataloging applications that are running and building this basic dynamic resolution around those services are running. So you can have the DNS resolver within Consul actually respond to queries coming inbound. But the real power comes when you up level a little bit and you start talking about this network infrastructure automation concept. And when you take that stuff you're discovering and those health checks that you're discovering and you feed those into some form of a network infrastructure. And in this case, we're talking about Nginx and Nginx Plus, but that could be all the way up to things like F5 big IPs and being able to leverage the discovery information that you're capturing within Consul to dynamically update these other platforms. And that goes back to the question I asked at the beginning of this statement: how do we create a dynamic environment in environments that were typically static? And that's really the answer. Is we take discovery as a foundational concept in Consul, the idea of discovering what these servers and what this infrastructure is actually doing, placing them into services that become the definition of what that service does. And we take that and feed that into these platforms that are able to do the networking inside of an environment. So the F5 in that example, or Nginx Plus, like we're going to do today. And we see this shift being more and more popular and more important for creating a consistent operating environment, right? We want to be able to have the same type of environment on-prem that we have in cloud, and we want to be able to have these same benefits in the on-prem environment that we have in cloud. Something to consider: ELBs in AWS or load balancers in Azure are expensive equipment to run. They're obviously more like a virtual service anyways. But the cost to you as a consumer for having those up, it isn't cheap. Understand that you could take Consul and drop it into AWS, do discovery against resources running in AWS, and then have that feed into an Nginx server and act as a load balancer for any of your applications running in the back end. You can do that same model on-prem, and now you have this consistent operating pattern between both of these environments. So I've talked a little bit about what Consul is. I don't think I need to go through line by line on this side, but there's a few kind of key tenets around Consul that everyone should take away. One is the concept of service discovery and health checking. So how do I understand what servers are supposed to be doing in my environment, or platforms or things inside of my environment? How do I take those, understand what they're doing, understand if they're healthy or not? And when I say healthy, we're talking about like some form of health check on the device. Maybe I'm asking it to look at TCP 5432 to make sure Postgres is up, or maybe I'm checking port 443 and making sure I'm getting a 200 OK back. Those are health checks. And if something's passing health check, it's in the service. And if it fails health check, it drops out and isn't available for resolution. That's that dynamic nature that I was talking about previously. Moving up a notch, I talked about this already, was the concept of network automation and how we use Consul to drive automating these network platforms that you have inside of your environment already. Both of these can be done completely in the open source product. There's capabilities that tie into what we're doing from an enterprise standpoint, because once you start doing this, you transform your environment into being more of a platform. And you have this operating alongside things like DNS in your environment. And what ends up happening is you want that to be just as stable as those other platforms. So you drive things like reliability inside of the environment, resiliency, and you want automated backups. You want to be able to have read-only scaling nodes that keep the service up and able to respond to these queries. So there's definitely an enterprise path there, but you can get started with this today inside of your own environment. And then finally, there's the service mesh concept. How do we up level that communication into proxies and have the proxies handle this communication, which is a little bit more of an advanced path and a little further down the road. And there's a great story there between what we're doing with Nginx and F5 as well. But today we're focusing more on the load balancing story. This is a screenshot of what that actual registry looks like. You can see this is very, very basic environment. This was used for the actual demo. This is running out of my lab at home, and I've discovered a couple of different services running within this environment. So I've got an API service running, a database that's connected via the proxy front end, back end Redis instance. This is just an operator view, if you will, of the actual user interface for Consul. So let's take a look at what a typical environment looks like. A typical environment might have an Nginx server sitting in front of 3 backend servers. It's funny, I can think way back to my first days working in a lab at home and having my own we call them home labs, right? So I remember using Nginx to reverse proxy a bunch of services that I was running inside my lab so that I could access it from my phone when I was out traveling around. Clueless Cody, not knowing anything about real enterprise environments at this point. But Nginx, that was my first experiences with Nginx, was using this to kind of reverse proxy backend services inside of my environment. And in the enterprise, you might see somebody have this app that sits in for, or this Nginx server that sits in front of these app servers behind. And it might be app.labinv.com that load balances in some intelligent way between these 3 nodes. And that works fine, right? That's probably a few hours of time to set up and get running, bullet tested for production. But what happens when you need to expand that, right? So this project is done. This app has been rolled out. Nginx is sitting in front of these app servers now, and the app is serving. What happens when they scale and they go to adding in 2 more nodes? And those nodes now are on different IP addresses, right? Because you've eaten up your contiguous IP space. So now that 25, 26, and 27, that 28 through whatever is now eaten up by other services. So when you drop these 2 new servers on, they land in 49 and 50 because that's what your IPAM gave, or the spreadsheet that you checked a couple of boxes on for IP addresses. That's what it returned. Now you have to go back and you have to do these day 2 operations where you go out and you file tickets with the firewall team saying, hey, I got 2 new app servers, 49 and 50. I need to add them to this firewall ACL so I can have access here. You need to go back into the Nginx front end server and add these to probably the upstream or some other configuration item, right? Like, these are all manual steps that you have to do. And it's not that different than when you rolled out the application the first time. You're having to go in and redo a bunch of work to add just 2 more servers. And once you do that, it's fine and everything communicates, but there's a lot of work in that. And it's work that you already know the end state of. You know that these servers are part of that app, right? If that app's a front end store application, you know that all 5 of these servers are front end store applications. You shouldn't have to go in and say, I've added these 2 servers. Let's go redefine what these servers are. Like, they should just be part of that group, and we should be able to use that information to dynamically update the platforms that consume that front-end store application. So James did this demo a little while back around the same demo we're doing today in a different way, using something called Consul template. And when we look at Nginx open source and how you can automate the Nginx open source platform with Consul template is the way we go. Consul template runs on your internal infrastructure, whatever platform it is, in this case, Nginx. And what it does is it dynamically generates configuration files based off of information in Consul. And that's like a big series of words, so I'll unpack it a little bit. Consul template is able to look at Consul and say, hey, I see a service here. What are the IPs for every node within that service? And how can I dump that into the configuration files for Nginx? You then fill in these directives inside of a template file that lives locally on that Nginx server. And every time Consul template sees a change inside of Consul, it pulls that change down, renders a new template, and then reloads Nginx with that updated configuration. So think about how that plays in a production scenario. I deploy 2 new servers. Those servers register against Consul and say, hey, I'm here. I'm a front-end service. Those get added to the front-end service inside of Consul. Consul template on the Nginx server sees this and says, hey, I see updates. I see new changes inside of the environment. I'm going to populate these into the Nginx config and then reload it. So now we've achieved that dynamic load balancing. And this is like the same type of behavior in general that you get inside of like an ELB or inside of just a general public cloud load balancer, right? In a public cloud load balancer, you auto scale your group and it just pops into that load balancer, be it via tag or via some other construct. And there's obviously deeper integrations and benefits that you get to ELBs or existing native load balancers inside a public cloud. So this isn't meant to talk bad about those. It's just to say for basic load balancing scenarios and even to advanced load balancing scenarios, you can get that same level of agility using Nginx and Consul template. But there's still a manual process there, right? Like, you still have to install Consul template. You still have to configure Consul template. You still have to build your configuration files. All these things are things you still have to do. And while it pays off for you because you do it once and it automates it forever, it's still work that you have to do to build those configuration files out, artisanally crafted for that one environment. Let's talk a little bit about how we bring Nginx Plus into this and how we expand that automation using Nginx Plus. We have this Learn guide out on HashiCorp Learn. It's a guide on actually getting started with Nginx Plus. It's a great guide at how you can actually quickly start doing this inside the environment. I used it when I went through and tested this out and smoke tested the environment. It works great. Definitely take a look at it. It's on HashiCorp Learn. I got a screenshot right here, so it's a great read. Go ahead and check that out. We have a lot of guides on Learn, a lot of good stuff inside of Consul. So here's how that configuration changes now inside of Nginx and within Consul. And I needed to make a little update to this screenshot. So sorry, James, I didn't do that, but we'll talk through it anyways. On the left, we have our Consul service registration. This is how we register the service against Consul. So this sits either on the server as like a local configuration file that is read when Consul starts up, or you can push it into Consul via API, or a couple of other methods exist too, like Terraform and such. So what this is doing is it's saying, hey, register an application called app. It's going to live on port 80, and we're going to check it by curling localhost. And if that curl returns successfully, we know it's good. This is pretty much the most basic health check that you could ever do. There's not a lot of intelligence here. We can get pretty advanced in these health checks. We can look for return codes. We can look for regex responses. We can check TCP ports. There's a lot of stuff that we can do from a check perspective. This is really meant to just show a basic check. On the Nginx side of the configuration, you can see that on the bottom, we have this upstream directive that we've set up, and we've called it upstream app. And we set the zone for it. And then we've said, hey, we're going to go ahead and pull the members of this from this record inside the environment. And in James's demo, I believe that it's equivalent to service.local instead of the service equals. This came from the Learn guide, so it was taking a little bit of a different path. But what this allows Nginx Plus allows us to do is go in and look at app.service.consul and grab all of the response records from that DNS query and dynamically feed it into the upstream. So instead of configuring out Consul template, instead of setting up all these configuration files, the template files, and relying on it to render, Nginx Plus in this case is just going to continually check that DNS query, or the DNS query for all members of that response, and populate the upstream for it. Anything you wanted to add on to that, James?
No, I think that's a great description.
Awesome. So let's take a look at how this changes now when we bring Consul into the picture. So when Consul's installed in the environment, that Nginx server ends up having a Consul agent running on it. So now that Nginx server is registering against Consul. It's got a member inside of the Consul environment, and Consul's able to actually pull resolution details out of it. We go through and we update our backend servers to also have Consul agents, so they're registering with Consul. So Consul understands that, hey, these are front-end app servers or whatever they are. It's registering those as part of that service that then that Nginx Plus server can actually consume. They're feeding their data back in, and Nginx Plus is dynamically updating with those that membership detail. So when we scale this up from 5 servers now to 10, it's automatically seeing those new servers and adding it to its actual resolution. So we're getting that dynamically. And now this is completely hands-off operation. Every time we scale out this environment or we add more servers to it, Nginx Plus is just going to see that and consume those new members. How are we looking, James, on the demo front?
You're just in time.
All right, I'll go and stop sharing and you can take back over.
So as you can see, it's finished deploying here with Ansible and no failures. Hooray. And again, feel free to ask any questions in the QA panel. You'll find the button down below. But just to review quickly kind of what was achieved with this, and we'll walk through some of the configuration and what was happening. But we've actually set up these 4 data centers with a load balancer, 3 caching nodes, and a console node. And the caching nodes are pointed at the origin mirror server for the upstream for the origin. So we'll be able to connect to any one of these and use it like an apt repo. And that's all done using the console service lookup. And to kind of break down more what's in each data center, within the regional data center, we have the load balancer, we have the service and monitoring provided by Consul, and then we have the caching nodes. And then on the machine that's actually deploying it, we're running Ansible and Terraform. We're doing Terraform first to lay down the VMs and the initial infrastructure, and that's actually being done in DigitalOcean. But that can be done in VMware environment. You could do it with bare metal. This will work no matter where you decide to deploy the solution. And then to kind of break it down, just with the we're just going to look at the Terraform, the main TF for Terraform real quick. And I see we have we can share the repo link. That's fine. We can cover some more of these questions at the end too. No, we are using Nginx Plus because I'll get to that in a moment. You can't do the service discovery with open source, and that is kind of the beauty of using Nginx Plus with Consul and using this feature functionality. But so basically what we do is we set up the storage and the mirror origin server, and then we set up all the volumes for the caching nodes and the VMs themselves, and then we set up the load balancing node, which without any extra storage, because it doesn't need it, because all it's doing is passing traffic. And then we attach all the volumes here at the end. And then with Ansible, we kind of, in this particular example, we have basically the main deploy playbook, which calls out to other playbooks that are included. And, because we want to install Consul on the load balancer and the caching nodes and the console node, obviously. But we don't need it on the origin. And then we have different playbooks that get included for specific groups. And the reason that it's done in this way is we only wanted to do like gathering facts once and kind of streamline the deployment process instead of having to kind of restart on every playbook. So it's kind of like a master playbook here. And the magic of what makes this all really work together is if you look here in the template for the Nginx load balancer configuration, there's 2 key pieces of config that you really need to make this work. You need you need to define your resolver, and typically you would want to set a short TTL, because you want to be updating these upstream servers every so often, and we set valid for 10 seconds. Now you can set that lower if you want it to run faster. You don't want to set it too low, or you're going to be doing too many queries over a period of time. But you want to find what a reasonable amount of time is for your given environment. And then the other thing that's really important is you need to set up a zone, and zones are really only available inside Nginx Plus. And then this resolve tag. So both the resolver and the resolve tag are only available within Nginx Plus. And what that tells Nginx Plus to do is, okay, so we're giving you an FQDN here, and what I want you to do is I want you to resolve that against the DNS server and actually do service discovery lookup, so it gets all the nodes that come back within that through a DNS lookup against the Consul server. And so if we look here, we'll just go to New York 1 because that's the one that's closest to me. And I'm going to bring up the Consul interface here, and we can see all the services that were deployed. And look, and the other thing with this, we actually have this set it up in a federation type of environment, so we can actually, you can see that I went to the IP address for NYC1, but I'm actually looking at the London data center. And we can click through all of these other data centers here, and we can look at all the services that have been set up. We can take a look at all the nodes and all the data centers and see all the health checks are passing, and it's really, really happy. And so what we want to do from here is I just want to verify, and this should work because it's passing its health checks right now. We can see that, we're getting through to the apt repo, and we can actually see all of the nodes that were added for the upstreams by looking at the Nginx dashboard. Now the dashboard is an extension, is only also available with Nginx Plus, but it gives you a lot of good visual data to see here. And if you can look at the HTTP upstream, the zone that we have here is caches, and we're using 40% of the memory there. And you can see all three nodes have been looked up and resolved here via Consul. And so that kind of shows you how dynamic this can be and how powerful of deploying Nginx Plus with Consul can be. And kind of show no trickery here, I'm actually going to take down one of these nodes. I'm going to turn Nginx off. Let's say we turn Nginx off on this guy. So we stop the Nginx service. You can see that it's failed, right? And then we'll go one step further, and it's actually Consul's removed it from service. That's why it went away from the upstream, because if we go back and look at the Consul interface, we go to NYC1, we can see we have one cache node down, and it's taking it out of the list of servers that it's returning when you do the catalog query. And if we bring that machine, if we bring it back up, we should see it return rather quickly. You can see it's back now. And if we go back to the Nginx dashboard, it should come back shortly. There it goes. And it's back. So, I mean, this is, again, shows how dynamic and how quick this can be. And this is, I have to say, I've been working with HashiCorp stuff even before I was at Nginx. And this is one of the coolest utilities you can have for creating those dynamic and very agile environments, no matter where you decide to run your applications. And so I'm going to leave it there for now, and I'm going to pass it back, and maybe we can answer some questions or cover some more information. Cody?
Thanks, James. That was awesome on the demo front, man. Just grabbing the share back up. So James walked through kind of what he was doing from a from a demo standpoint and where everything lived within the environment. So I think there's generally an understanding what the architecture of the demo looked like at this point, so we can cruise forward here. I think it's probably best to go through some of the questions, James, and start to answer a little bit about.
You know what I forgot to do?
Yeah.
I forgot to show app actually working.
Oh, wow. Yeah, that's kind of important.
That is important. Let me do that.
Go ahead and show that.
I knew I was forgetting something. There's always that one thing. So let's get that. And so what we'll do, we'll go over here and we'll edit my sources list. And I did it again. Hang on, no, it's over here. We want, there we go. So with the Nginx one, we're just going to duplicate what we have here. Because we're basically mirroring what's there at the Nginx org apps repo. And then sudo app update. Oh. Typos get you every time. What did we, oh. Yep. Had a typo. Should have caught that, Cody. There we go. So you can see that it was able to update here using that IP address. And if we do app cache Madison, and we look for Nginx, we can actually see the Nginx packages are actually available via one of our via our load balancer, which has the content caching behind it. So everything's happy, everything's working. There you go. Back to you, Cody.
Yeah, so I think we're going to move into answering some of these questions live. A few of the questions that are left are very, very like, I would say Nginx Plus style questions. So I'll lob a couple of those at you and see if we can test your might. So yeah. First things first, let's going down the list. We're going to say, can one still roll out Nginx Plus HA clusters with Consul load balancing in front of it to load balance between multiple active instances of Nginx Plus? I think I know the answer to this, so I'm going to test it with you and see if you agree. Like, you could, in theory, use Consul's like service discovery to have two Nginx Plus behind a service in Consul and have it resolve both of those. However, Consul has no knowledge of like sticky sessions. So if your app is expecting it to pass all the way through the same place it started at, Consul is always going to just round robin by default between the two services in that environment. So I don't think it'll work in that way, but James, I'd be interested in your feedback on it.
It won't work with open source, but it will work with Nginx Plus because we have the capability of doing persistent and zone synchronization between Nginx Plus nodes. So the persistence will actually be maintained between both nodes. The hash tables or the algorithm in which you use for persistency will be maintained, and the session tables will remain in sync between, actually, not just both nodes, any nodes you decide to put in a load balancing cluster.
So that's interesting. Like, obviously learning a little bit about Nginx Plus, not being more on the open source side. That's pretty awesome. That like it's like a cluster in the truest sense of the word, and that it's sharing its information into two, and they're able to react to knowledge that either one of those instances shares. So we could, in theory, have app.service.consul sitting in front, and the person could be hitting that and have no issue with it, regardless of if they're hitting server or Nginx A or Nginx B. It's going to pass that persistence all the way down. That's right?
Right.
That's super cool and super useful. So
in that way, it looks like one giant load balancer at that point.
Yeah, that's pretty powerful. So next question: if you take down one Nginx Plus instance from the group, but it has not refreshed within the 10-second window, will the request be dropped or routed to another available instance?
It should be routed to another available instance, because if you have the active health check on, which again, hate to sound like a sales guy, but that's what I do, is only the active health checking is only available in Nginx Plus, and that will actually catch that error and be able to push it to another node. Now, in open source and in Plus, if you do not have the active health checking set, it will eventually catch that fail, but it will, the transaction will fail, but I think Nginx does not supply a response. It actually, if it's within the TCP try window, it'll just allow the TCP to try again and route it to a next available node. I think that's how it works. I could be wrong, but
awesome. Do we support connection draining if we want to take a web server out of the pool?
Absolutely, but only in Nginx Plus.
A lot of in a sales way, there's a lot of reasons to buy Nginx Plus, isn't there?
Yes.
So there's the question. It looks like it was in response to the one that I typed. Gotcha. So then it shows a health check as a red arrow, and what I'm not clear on is that the load balancer N is actually doing health checks itself. So there's I think there's a couple of paths here. Nginx Health Plus, as James just mentioned, has its own health checking within itself as a platform. Consul itself can be running health checks on nodes within that environment. So in the demo example that we showed here, you would probably be using the health checking on the Nginx Plus server node for itself, and then Consul, as nodes within that load balancer pool fail health check, it's just going to remove them out of the pool. Nginx Plus is never going to know about those nodes because Consul is just going to drop them out of the service. For example, if it's checking port 80 and one of the app 03 stops responding on 80, all of a sudden Nginx Plus is just going to see 1, 2, 4, and 5.
Right. So in this particular example that we showed in the demo, we were doing active health checking and also defining a health check inside the service registration that we did. I can show that to you if you want. But the ability to be able to do health check both from a Consul perspective and from an Nginx perspective allows for faster failover and being able to get that node out of the list or not have traffic sent to it anymore. And basically, because if you remove that node, you need to make sure, because it needs to recalculate that hash table and get the new sessions going.
Yeah, so and I think what we're hitting on here is there's definitely a little bit of an overlap. And there's, in the sense of health checks that Nginx Plus can do and health checks that Consul can do. I think the presentation sort of hurt the story a little bit on more on my side, in the sense that I showed a very basic health check. Consul health checks can get extremely deep and extremely granular. And there's when we're talking about just, hey, as a web server up, it's 6 in one, half dozen in the other. I don't think that there's any major reason why one shines light years above the other.
Right.
Well, so there's definitely a slight overlap there. I don't want to take away from either side on that, because I think that's what the question was alluding to, is well, couldn't I just do the load balancer check natively and then have it drop services out as needed? But what you're not going to get in that is you're not going to get the discovery of the nodes. Nginx Plus will handle dropping unhealthy nodes, but what you're really getting here is the discovery, and then you can rely on Consul or Nginx Plus to remove unhealthy nodes as needed.
Right, because you don't want a node that's been taken out of service still on that list.
Exactly.
Right. So you want those health checks in both places, really, and they're providing two different functions, right? Because the load balancer itself is checking to see if the upstream server is even and with that simple health check is making sure that the endpoint is just responsive at all, right? But what the one that we defined in this particular demo is actually testing that the caching service is working, because it goes to a specific URI within the Consul health check. And so that particular URI is what's providing the caching service. And that's what's been registered to be defined as that service inside Consul.
Perfect. So next question, can Nginx proxy IMAP, POP3, and SMTP protocols? Do you have any successful case for email service?
Yes and yes. I don't have an exact client name in mind, but we can definitely proxy mail services Nginx supports doing UDP and TCP proxying for pretty much any protocol that you can perceive. You have to be aware, though, if you are doing the stream type proxying, you are going to end up using more ports because there's only certain protocols that support keep alive, right? So if you are doing it to a backend HTTP or HTTP service, I highly recommend doing it using the HTTP context and being able to kind of use it more like an API gateway or application gateway that way. But if you need to do like things like mail or SMTP or, RTMP, being able to proxy that stuff, we can do all of that.
Awesome. And final question: Can this work with sticky learn option enabled?
Yes.
Awesome. That was an easy answer. And then
I see you, Devish.
Another question popped up. Can we do load balance traffic, or can we do load balancing of traffic based on geolocation? That's a yes, right? Like there's
absolutely. So, but the thing is, you have to front end your DNS zones that have the capability of doing traffic-based geolocation, right? Also, you can actually do some really cool things with Consul. Is if you're federated like we showed in this example, and you actually have that that layer 2 cross connect between your data centers, or at least layer 3 cross connect, so you can have traffic routing, and you've got your federation set up correctly, you can actually set up, what your primary data center is, where for that location, configure your upstream to do the query for that given data center, and then make a data center, a different data center, your backup. So if all the nodes happen to be down, or that service happens to be down on that data center, you can dynamically reroute traffic over to the other nodes in the other data center through Consul Federation.
Awesome. Alan asked, what would be the better way to scale Nginx in the setup? Vertically scale by running Nginx in bigger servers, or run it behind Consul load balancing and horizontally scale it? Does Nginx HA cluster support more than 2 instances? Can you answer the end of that first?
Yes, we do support more than 2 instances for HA clustering.
I feel like I tend to like many smaller servers personally. I think I take more of like a microservices approach to that, not in the traditional microservices world, but like I think that the day has kind of passed of these monster like 32 gig load balancer boxes, right? Like, and spreading the load out amongst many creates like a very smaller blast radius around failure, right? If you have 6 nodes in play and you lose 2, no one cares. Like, it's a drop in a pond. But if you have 2 monster servers and you drop one, you just cut yourself in half. Like, that's my perspective, but I'd be interested. You're the architect here on it. This is just from like enterprise world. What's your thought?
And well, so it really depends on the customer use case, right? Because if you have a customer that isn't typically using large amounts of microservices, they're not using Kubernetes, they're not using Nomad, right? They're pretty much reliant on on-prem doing VM, and that's how they run their applications. You can support running on larger instances or bare metal, however you want to run that traffic. So it really depends on the need, but we can scale either way. But Cody is right. The preferred method for doing modern architectures is running in, setting up a whole bunch of smaller instances to reduce the points of failure inside the infrastructure.
Awesome. Question was, can we use Consul template to reconfigure upstreams instead of resolution? Absolutely. That was what we'd shown in the very, very early part of the example when I said that James had done this before. I think your original demo, if you want to do just a 30-second highlight of what that one was, it was using Consul template, right?
It was using Consul template, and it was using Consul template to do the service discovery and to apply a template to the configuration, but that required extra steps and extra automation to make that happen. And so this actually, doing it with the service discovery with Nginx Plus, streamlines that ability and makes it far, far more dynamic and in my mind, far easier to deploy. Because you just set it and you don't have to think about it. With the other way, I had a whole nother several tasks that I had to do Like I was able to get rid of half of my playbook for
Yeah.
Ansible.
The thing about Consul template is a super powerful tool, and like using it for Nginx is one of like many, and arguably it's a pretty small use case inside of Nginx Plus. Like we see people use Consul template to do full configurations for applications into environments. We see people use Consul template to create pull-based automation where you update a key inside a console and it distributes to 1,000 servers and they all pull a new configuration in. The upstreams thing totally works and it's a great use case, and it's honestly like one of the most bulletproof solid use cases, but it is a pretty small, like lightweight use case for it. And it does have some work to get up and set up. Not that it's insurmountable work. It's just setting up a template, pulling the binary down, setting up a systemd job so it's always running, making sure you have a command that'll actually reload whatever configuration you're in place. Like there's a few steps for it. And from an open source perspective, getting it up and running, like there's no reason that anybody who has an enterprise, if you're running Nginx open source, there's no reason why you shouldn't be using it with Consul today. Like you're going to get better things out of it today, right now, bringing Consul template in and using it with Consul. And I say that objectively, not just as a HashiCorp employee. Like there's no reason not to. But when you start to do like more complex load balancing, more complex front end services, moving to Nginx Plus is fine, and being able to use the dynamic resolution and making it a more hands-off operator experience is great.
Well, I mean, the Consul is in my mind, the best, and I'm not just saying this because I'm on a HashiCorp webinar. I mean, the Consul is the best service discovery tool in the industry right now, period. I mean, that I mean that sincerely, because I've been working with it for years. I've been working with it for years, and it's always been my first choice when it comes to service discovery solutions.
We had another question about the Nginx Plus HA cluster. So Nginx Plus mandates the use of Keep Alive D. How can we put Consul load balancing in front of it then? Or is the whole point to use Consul load balancing for the upstreams? I think you would typically use Consul for the upstream resolution, most typically. The original question was, could you put Consul load balancing in front of two HAs? And like the answer is, yeah, you could. To the point of the question though, you're going to end up hitting like app.service.consul as your user-facing URL, which is going to be kind of a bad user experience. Like I would never recommend that like the front-end load balancing for an environment be Consul's dynamic resolution.
Well,
not really, like I wouldn't say that's the best place for it. What are your thoughts, James?
Well, actually, Keep Alive D is only required if you want to use VIP, right? If you want a cluster of load balancers sitting on the edge of your network, hopefully you have a firewall in front of it. Yeah. Needless to say, but you want to have it sitting on the edge of the network, and you want to use that geolocation load balancing. Throw all of them into the A record, and they'll just round robin right through. You don't necessarily have to use Keep Alive D there. You only have to use Keep Alive D if you want to use VIP, virtual IP between all the nodes, and that's if you're running a active standby model. But in this case, in more modern architectures, particularly when it comes to things like Kubernetes ingress controller, right? You want to use a smart load balancing system that can do geolocation, where you can have multiple entries in your A record, and it will round robin between them all. And the beauty of this is you can sync the zone together, and the load balancer just looks like one giant load balancer.
Great. Another question: once Consul health check realizes the backend server is running in a degraded state, can Nginx route less traffic to that particular backend? If you're using Consul for the discovery component, when Consul sees that health check failing, it's going to just take it out of the load balancer rotation. So Nginx is going to stop being aware of its existence at all. Like it's just going to drop off when Nginx runs its next resolution query, it's not going to be in the resolution list. It's going to be like it never existed at all. So you couldn't throttle the traffic down. It would just stop going there. Existing sessions would be like maintained. So if somebody was on it and it was running and like they were going in, but as soon as that refresh happens and it drops out of the upstreams, then I think everything's gone.
Right. But if there's still a session in flight through Nginx to that endpoint, Nginx will try to honor that session until it fully gets a timeout from TCP state on that. So even if it's out of the upstream pool, if you have a dangling session, it will try to finish it. And actually, correct me if I'm wrong, Cody, I could be absolutely wrong on this, but I think there are other ways of doing degraded state health checks where you can actually mark a node as a degraded state and actually mark that via the API and mark that particular upstream as a drain. That way the session, no new sessions will be sent to that node. And then once it comes out of that degraded health check state, you can remove that drain flag.
I think there are ways to do degrade. I need to unpack it a bit. I don't know if it's going to function quite in this way because like the resolution is kind of an on-off thing, right?
It's pretty binary, but I think there are ways to achieve this, right? So when you define your health checking, you define a health check script that may not necessarily report a failure, but it knows logically that it's in a degraded state and to activate that API flag for that given upstream.
Yeah.
And then if it ever comes back from that on the next health check pass, if it comes back out of that degraded state, it can change the API, then pass, or fail. And if it's still in that degraded state, you probably want to consider shutting down that node and having Consul take it out of the resolution. But there's ways of doing it. But again, it's something that, that's just hypothetical and would have to be, properly thought out before implementing.
Right. Awesome. Well, I think we cleared the questions. Oh, there's one more. Does Nginx support Consul SRV weights? And if yes, how does it achieve that?
It doesn't.
This one I don't know the answer to.
I'm not. So, Devish, he's trying to trip me up. This is a buddy of mine. He's trying to trip me up. So I don't know 100%, but I do believe it will actually, because we have weighting options within upstreams, and I think it will translate, but I'm not 100% sure. I can actually get that answer for you offline, Devish.
Awesome. Well, I think we're running up on time. Karen, do you want to bring us home?
Great. Thank you, Cody, and thank you, James, for a really informative session. We had a lot of questions. And thank you to our audience as well. I hope everyone enjoyed today's webinar and has a better understanding of how to unlock dynamic load balancing with Consul and Nginx Plus. There's also a short poll, which you'll see shortly, which we would love to get your feedback on. And finally, as mentioned at the beginning of the webinar, this was recorded and we will make the recording available after processing. I'll send an email to everyone who registered with the recording link. And with that, have a great day. Thanks to everyone. Goodbye, everyone.